Polymers. See, polymers are very large macromolecules which are having repeated structural units joined to each other through covalent bonds. These are large macromolecules with very high molecular masses of the range of 10 to the power 3 to 10 to the power 7 unified mass. So it goes from 1000 to, you can say, up to 10 lakhs. So it's almost like this. These are having repeated structural units. Now those structural units which are repeated throughout these long chains of these large macromolecules are called monomers. I can give you an example, like if this is a very simple ethene molecule, when these type of molecules undergoes the formation of these large molecules, the process is called, of course, polymerization. We get what? Large chains of these repeating units which are called monomers, and these large chains are called polymers. So polymers are large macromolecules which are having repeated structural units called monomers, and the process of formation of these polymers is called polymerization. We will first do its classification, which can be done by many different on the many different bases. Now let us take first their classification. Classification of polymers. The first classification is on the basis of their source, and on the basis of their source they are of three types: natural polymers, semi-synthetic polymers, and synthetic polymers. See, natural polymers are those polymers which are actually having they are obtained from the natural from the living beings or from the living sources, and they all are naturally available around us, and it includes your carbohydrates, your proteins, and the other molecules which can be easily obtained from the living beings. That are called your natural polymers. The rubber is also another very good example of the natural polymer. Now then we have semi-synthetic polymers. Semi-synthetic polymers are the polymers in whose the raw material is natural, which are then again chemically processed to give a better quality polymer, like rayon thread. Rayon is based on a cellulose. The cellulose is taken out, which is actually a natural polymer, and that is chemically processed to obtain a better quality polymer, which is called rayon. So, and similarly, vulcanized rubber, it is based on a natural rubber. Natural rubber is a natural source, is basically a natural polymer which is chemically processed to increase its qualities and to improve its qualities, and that is why the vulcanized rubber is a semi-synthetic. So the polymers whose source is a natural polymer, but it is again chemically processed, as such it is not directly used, and it is chemically processed to obtain a better quality polymer, are called synthetic polymers. Then the third type is of synthetic or artificial polymers. These are polymers which are completely obtained by chemical reactions in the lab. Like we have nylon 6,6 or nylon 6 or nylon 610. We can have polyesters, we have phenol formaldehyde or melamine formaldehyde or alkyd resins, or all sort of other compounds which are basically obtained in the lab by artificial reactions, by the chemical reactions which are done in the lab. So these are the three types of polymers we have on the basis of their sources. The second classification is on the basis of the structure of these polymers, and on the basis of their structure they are of three types: linear polymers, branched polymers, and network or cross-linked polymers. The linear polymers comprises of the polymeric chains which are linear without any side branching. So they are straight chain polymers are called linear polymers. Now these polymers can be packed very compactly with each other, so they will be having very high densities, very high tensile strength, very high melting points. Nylon is the best example of this. Nylon, polyester, etc. are very good examples of these type. Then we have branched polymers. Branched polymers are polymers which have side branches like this. Now due to these side branches, they cannot be packed closely to each other because of steric hindrance. As a result, they will be having what? Low densities. So low density polythyrene is the best example of a branch chain polymers. Then we have network or cross-linked polymers. These are the polymers in which basically are having a linear chain, but of course all these chains are actually linked to each other through number of cross linkages. Now these cross linkages, which are actually a covalent bonds, gives them a rigid three-dimensional structure, network structure, and that is why whatever the shape is given to these polymers, that cannot be changed, or they cannot be remolded again. So your melamine formaldehyde with the melamine unbreakable crockery, which we use in our normal household in houses. Then we have the phenol formaldehyde or Bakelite switches, electrical switches. We have all those are examples of your cross-linked or network polymers. Third classification is on the basis of the mode of polymerization, how the polymers are formed. And on this basis, they are of two types. The first one are called additional polymers. These are the polymers in which the monomers joins to each other across multiple bonds. Like this, I've given the example, like we have a vinyl chloride, which when adds up to another vinyl chloride by the homolytic fission of its pi bond, leads to the formation of this type of a polymer, which is called polyvinyl chloride PVC. Now, such polymers, remember, are called homopolymers. So, what are homopolymers? The polymers which are made up of, whose repeating units, the monomers are made up of only one type of molecule, are called homopolymers. Now, what is important about additional polymers is that in these, the monomers add to each other across multiple bonds. No loss of any small molecules takes place. The repeating unit resembles the monomer. Therefore, the molecular mass of the polymer will be integral multiple of the molecular mass of the monomer. So these are the important properties of additional polymers. So all your PVC, all your polyacrylonitrile, PMMA, your Teflon, and your other sort of those compounds which are actually like polypropylene, polyethylene, all these are your examples of your additional polymers. Now let us take the second type of this type of polymer on the basis of their mode of polymerization. The second type of the polymer of this type is called condensation polymers. Then these are the condensation polymers are the polymers in which the monomers adds to each other across functional groups. Remember, that's most important, across functional groups. Let me give an example. Like we have this is called hexamethylene diamine, which is when added to adipic acid, what happens is OH and H of this, then H of this, then OH of this, they all goes out. What we get at the end is this is what we have as the main monomer of the polymer, which is called nylon 6,6. Here the 6,6 means because both these this monomer is made up of two molecules which are having 6,6 carbon, and such polymers whose monomer is made up of two different molecules are called copolymers. So nylon 6 is an example of copolymer, and they are examples of condensation polymers. Condensation, why? Because the monomers are adding to each other across functional groups. Therefore, what happens is loss of small molecules like water, alcohol, etc. takes place. So chemically, the monomer is very different from the monomers. Like in this case, chemically, the repeating unit is having an amide linkage, whereas there was no amide linkage in the monomer. There were acids and amine. So chemically, they are different, and you can't have the molecular mass of the polymer integral multiple of the molecular mass of the monomer because loss of molecules takes place. But what is different is that they are adding to each other across functional groups, whereas the previous one done additional polymers, they add up across multiple bonds. That's a basic difference. So all your nylon, polyesters, phenol formaldehyde, melamine formaldehyde, all are examples of your condensation polymers. The fourth classification is on the basis of the molecular forces these monomeric chains are having between them. And on the basis of molecular forces, polymers are of four types: elastomers, fibers, thermoplastics, and thermosetting plastics. First, let's talk about elastomers. As the name indicates, yes, these are the polymers which are having a tendency of what? A property of elasticity. Now, why they have? Because they are having highly coiled structures, polymeric chains, which are having very few cross linkages and the weakest intermolecular forces of attractions. Now, due to their coiled structures, they can be stretched to their full length, And because of those few cross linkages, they can when that force is withdrawn, they can retain their shape back. That just gives them the property of what? Elasticity. But they have weakest intermolecular forces, and all your rubber and your polythene, low density polyethylenes or high density polyethylene, like the examples of your low density specifically, are having the property of elastomers. But all your rubbers, natural rubbers, artificial rubbers, thiocol or your buna-N, all are examples of your elastomers, which have the tendency of elasticity. Then fibers. Fibers, as the name indicates, they are having what? Fiber-like structures. They are long chain, they are linear polymeric chains, which are actually coiled together, very closely packed together to give them a fiber or thread-like shape. So they have a very high tensile strength, they're very strong, they have very high melting points, and they are packed together very compactly. So all your nylon threads, polyester threads, all are examples of your fibers. Then we have thermoplastic polymers. Thermoplastic polymers, remember, before going to the third one, fibers are having the strongest intermolecular forces of attraction, which are having hydrogen bonding, which they involve hydrogen bonding. As a result, they are having the strongest intermolecular forces of attractions. Now let us move to third category, thermoplastics. Thermoplastic polymers are those polymers in which the forces of attractions are in between elastomers and fibers. Not as weak as elastomers, not as strong as fibers, but yes, they are of in between. But what is most important is that they don't have any cross linkages. They don't have any cross linkages. As a result, what we find is they can be remolded again and again, and they can be given any shape. So all your polypropylenes, polyethylene, high density polyethylene, all these are like the examples of your thermoplastic polymers. Then we have last, thermosetting polymers. Thermosetting polymers as such are basically existing in the semi-fluid resin state, which on chemical treatment, they are long chain polymers which are existing in the semi-fluid resin state. But on chemical treatment, what they do is they form what highly dense network structure, due to which they attain a three-dimensional cross-linked polymer structure. As a result, whatever the shape is given, they cannot be remolded again. So due to those cross linkages, they cannot be remolded again, and as a result, they form a very rigid three-dimensional structures. So those are called your thermosetting plastics. Melamine formaldehyde, your phenol formaldehyde, these all are the examples of this type.